This video provides an example of regular summary statistics or descriptive statistics and finding the minimum and the maximum and percentage, general description, exploratory data for a specific example. I'm going to do this in R-Markdown, so I'm going to provide a title here. Let me call it our tutorial summary statistics sample exercise, and I'm going to choose the output R-Markdown output document to be in the PDF format. I'm going to hit OK. This is what you see. I'm going to leave the first R chunk as it is. I'm going to probably delete the rest of the information down here. Since I will be providing my own note. Since I've chosen the R-Markdown output document to be in the PDF format, if you have never used it or if you have not installed it on your computer before, you need to run these codes, but I have already done it, so I don't need them. I'm going to comment them out so that I don't have to worry about it. If I don't have it, when you need the document at the end, it will throw an error message. So we need to do that. I can probably just delete this information. I'll be putting my own notes. Okay, here I have used the heading level 1 with one hash tag, and I'm calling it the heading I'm giving it is R for econometrics, summary statistics, sample exercise. For this sample exercise, I'll be using a variation of MEAP01 from the Oldridge package. It is a cross-sectional school attainment data containing information on 4th grade math scores, and the variable name is math4. 4th grade reading scores, and the variable name is read4. Expenditures per pupil, EXPPP, and other variables gathered from the survey respondents for the state of Michigan in the year 2001. This sample computer exercise requires you to gather descriptive statistics for these variables and to compare the difference between the schools with different amounts of spending. So basically, if spending is associated with any of the outcome variables we have that are of interest to us. Before we do that, we need to install the necessary packages in order to read this data. So I've already installed those packages, so I don't need to install them again. But what I need to do once I do it for the first time, I can just comment them out. But I need to load those packages. Okay, I'm going to run this R chunk. I can either go from here, I can run the selected lines or run current chunk. Even easier, I do Control Shift and Enter, so it runs. But this is a message that throws out here in order to cite this Stargazer package with this name, with the appropriate citation. After putting them in the library, now we're ready to load the necessary data from the Oldridge package. Again, we're using the Oldridge package to read the data, and we're going to be using Stargazer package to calculate the summary statistics. So I'm going to run this chunk. It runs OK. I'm going to hit this chunk, and well, before I do that, let me show something. So what we have down here is the data set, data frame, and if I click here, it opens. There are 1823 observations, 11 variables, and this data, if you're reading from Woolridge for exercise or for some other example, other exercise. There are different versions of this data set. So the particular version I'm using has 1823 observations, and the variables are normally the same 11 variables. The key variables that we are interested in is, again, we will look at the math scores and the reading scores and probably expenditure per pupil. So these are the variables we have available here. But I'm going to do a few examples that are going to ask us to look at the minimum, maximum. So there are 1823 observations. Now we need to find out what each variable is going to look like. At least, do the summary statistics, mean, median, standard deviation, maybe correlation between two variables. Those are the standard summary statistics or the descriptive statistics we want to look at. So let me close this and then go back to the this command here, code, to calculate the summary statistics. And I don't need this. So star gauger, I'm providing the data frame, data set name, and type text. If I do that, it's going to give me the summary statistics. It's a nice table here. I'm going to make this part of the screen a little bigger so we can see a nice table of summary statistic. So there are 11 different variables. N number of observations equals to 1823. Here are the mean values for each of the variables. Here are the standard deviations. Here is the minimum for the D code variable. That's for district code, I believe. And then this is the 25th percentile, or the first quartile. This is the 75th percentile, or the third quartile, and here is the maximum value for the variable. So you can do the same thing for each of the variables. There will be questions that we will answer about math for and read for. Here is the mean values, here are the standard deviations, here are the minimum values, and so on. And here are the maximum values. So that means there are certain school districts with a low score of minimum score of 0, and there are some schools or school districts that have perfect 100% outcome. Now it will be better once we know the exact question that we need to answer. It will make more sense. But for now, that's what the general description of this table is, that we have these statistics available. Okay, here is the first question. So question number 1, and there could be other questions, but I'm just going to do a few of them. Find the smallest and largest value for math 4, and that's why we calculated this summary statistics. If we look at this particular row, for math 4, minimum value is 0, maximum value is 100. So it can be found on the table. The answer is the smallest value is 0 and the largest value is 100. Okay, so that's how, and the way I'm writing these answers is because this I was using as a second level heading. Then I'm using these stars in order to put my answers and comment, or the description that I want to provide as an answer to this question with these star signs. The next question is asking how many schools have perfect pass rate on the math test. So what this is asking is, if we look at this data, so we have this math 4. So this school has 83, 90, 61, 85%, 77%, and if you go down, there are certain schools with 100% pass rate. So what we need to do is, I mean, we have 1823 observations, so it's impossible to go down the column and count them manually. So we need to find a way to count how many perfect scores or how many 100% do appear in this column. So here's the second, third one. So we need to write some kind of code for that. So here is the code. What we want to do is we're going to call it math4 underscore 100. I'm just assigning a name. And then I could even do, what I could do is, I mean, if I do it this way, it will probably not be attached to the data set. So let me change this to so MEAP01. So this is the data set we have, data frame we have. I want to add a new variable, math4 underscore 100. And this is just a name I'm giving. So if you look here right now, on there is no math4 underscore 100 variable. So if we go here and run this code, it will generate this variable in this data set. But how is it going to generate is it is going to go to this data frame and then look at this math4 variable and then find out how many of those math4 scores are equal to 100. So when I run this, what I see here is this. So we have math4 underscore 100, a new variable, and you see that all of these variables, so it is false, 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 because math4 is not equal to 100 here. So if you scroll down, it's all false, 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 and then keep going down. And here is a true. So if you look at this particular observation, so math4 equals to 100, and math4 underscore 100, it's the new variable I generated, it's true. So although it is labeled as true, what it does is it's a boolean, so it is going to get a value 1 if it is true and value 0 when it is false. So what we can do is to count how many true values are there, because we can do the mathematical operation when we calculate this variable this way. So I'm going to go back here and then see what I am going to do is find the sum of MEAP01, so math4 100, and when I ran this code, it tells me that there are 38 observations, true values for that math4 underscore 100 variable, the new variable we generated. So the answer is, I'm going to write it, answer is there are 38 schools with perfect pass rate. That's how I would answer it. And the reason I am writing these answers here is when I knit the document, it is going to produce a PDF document, and that's what I can submit it to my assignment that I'm supposed to, or if you want to email it to somebody else, or if you submit it to wherever you need to upload it, it's going to show up as a nicely formatted answer. We'll see that at the end. Next question is related. The number of schools that have perfect pass rate on the math test represent what percent of the total sample? Again, we know there are 1823 observations, 38 out of 1823 do have perfect pass rate. So if I run this command, what I see is down here, 2.084476. Since I assigned this name %1 as a value. It's not going to show up here. So rather, what I would do is answer, and then I could simply I could copy this, or I could simply write 2.08. Let's say 45 if I round it up to 4 digits. Here is another question. How many schools have math pass rates of exactly 50%? Very similar to the previous question. And again, I can do the same thing here. I can generate a new variable to the existing data frame. So I'm giving it a name, math4_50. And if I run this, what's going to show is an error code, because I should put the same thing here. Okay, and the answer is 17. And just to make it look nice, complete, I would put this answer down here. Here is another question. What is the average pass rate for Math 4 and reading test? So we need to see the mean values of Math 4 and Read 4. And we can see that Math 4 and Read 4, Math 71.91 or 909, Read 4 60.062. And I put the answer down here with this dash sign, so it'll, when we knit it, it will show as a so we will see the difference between using star and dash when we look at the PDF document. The next question says, what is the correlation between Math 4 and Read 4? And you can, this is the command code to calculate correlation, COR in the parenthesis. You would put the variables. I'm just going to run it, and I see that the correlation is 0.8427. And I can put it, answer is 0.8427. Let's look at the table up here, and the expenditure per pupil is this variable. Average is 5194.86, and the standard deviation is 1091.89. And here is how I would write my answer so that it goes to the R-Markdown document when I need it. Okay, so here is another question. It asks, what is the coefficient of variation? We need to calculate that. See if CV has high variation, if it is greater than 1, or low variation if it is less than 1. And the CV, coefficient of variation, is a way to look at the variation in the data, in the variable of interest. And what we have here is, we look at the formula for this is standard deviation divide by the average of the variable. And if we run this code, what we see is that the value is down here, CV equals to 0. So I would write it down. I would write the answer here. Okay, here you see answer is CV equals to 0.2102. I just rounded it up, and it is a low variation since it is, oh yeah, that's right, it is less than 1 as defined in the question. The last questions, question or set of questions in this example ask you to compare the per student spending for school A with 6,500 and school B with 4,000. So what we need to do is calculate the percent difference between the two schools. So A spends 6,500 per student, B spends 4,000 per student. So as a percentage of this school B, this difference is simply we can calculate it as with this formula, and we get the answer is 62.5. So what we see here is that school A or school A's spending exceeds school B's spending by 62.5% more. And you can do the same thing. There is if the questions question asks you to calculate this to find the answer using the natural logarithm, you could use this formula. So spend percent underscore ln, I'm just assigning a name. You can calculate the difference in the log of the two values. So instead of trying to find the compare with 4,000 spending, you can simply find the log difference between the two values and multiply it by 100, and you get the answer to be slightly different. So this approach, since it is giving a different answer, we need to be careful when to use natural logs. You may see that in a lot of the econometric models as we go, we may have to use natural logs, but that is true for normally for small values of for small values. If you calculate the percent difference this way, the first approach or the second approach, you should get the same answer. But for a lot of the economic indicators such as the inflation rate, interest rate, GDP growth rate, for those values, it may not make a huge difference. But normally, if we do it for other values such as GDP or salary or export import, these monetary values, we tend to use logs in econometric models to smooth out the data, and they could be a good approximation, but keep in mind that when you calculate it this way, you may get different answers. So that's what I wanted to show here. That was the set of questions I wanted to present here, and we will knit this document and produce the output in PDF document. If I knit it, it's going to ask me to give it a name. And I'm going to call it our tutorial. And then I'll just give it the same name. Summary, statistics, sample, exercise. And hit save. And as soon as I do that, here is the output. And I'm going to zoom in. So here are all the codes that I used. Here are the headings and the first level heading and the second level heading. And here is the description I have provided. And one thing you notice here is the output has these hash or pound signs, but the table is here. So I may want to remove these pound signs. And to remove the pound signs from the output, what I just did here is, if you put so in the initial R chunk, echo is true, it shows the output, so leave it there, but comma, and then I'm adding comment equals to NA. Now, if I knit this document, what it is going to do is it should remove those pound signs. So if you see here, this is nicely formatted. So here are the commented codes, here are the headings, here are this is when I used the star as a bullet point. Again, here is another level and third level, and then when I was using the question, so comments for question 1, question 2, and then my comments. Here are the answers. Here is question 3, here is question 4, and so on, question 5. So it's always a good idea to make your R-Markdown document output as clean and as organized as it can be. So be sure to write down the questions, be sure to specify which is the answer, be sure to show the codes that you have used. So this is a pretty good document, and what so this is the output you see when you knit the document, but you can explore this once you close it. Then you have to explore it from within your computer where you have saved it. And on my computer, so this was the code I was using earlier. So this R tutorial, summary statistics, sample exercise. This was the R Markdown document I was working on. So when I knit it, it knits in the same location, and here's the PDF document, R tutorial, summary statistics, sample exercise, and here is the preview of that document. And then if I open it, it's going to open in a PDF reader, so you whatever PDF reader you have. So now you should be able to submit this to the assignment folder. Now, if you needed this in a Word version, all you can do is here, instead of the PDF document that I had here, you can change it to Word, and you can knit it, and it should open your document as a Word document, and it's right here. Okay, so here is the Word document, and you can edit any of the things that you want, if you want to remove or add some things. And if you wanted an HTML document, you change this to HTML and knit it, and you should get the HTML that opens in any of the web browser that you can open, and the answers and other things remain the same. And what you see is, as you knit them, and if you go see the Explorer, Windows Explorer, so you see that at the very bottom of this, all three, the Word version, HTML, and the PDF version, all of them are saved in this folder. So as you go, you may want to create a different folder for each assignment, each project, or each new thing that you do, so that you have a well-organized file system in your computer. So I should have done that. Right now what you see is all these are tutorials I have made for other purposes, doing different testing, importing different data files, installing installing packages like the one TechReg package, and making tables. So that's you should, it's always a good idea to organize so that you find them when you need them and when you want them, without having to spend too much time. Okay, that's all I wanted to do in this video. So